CESC Limited serves more than 3 million consumers spread over a licensed area of 567 square kilometers. CESC is a forerunner among Indian power utilities for embracing various new technologies, both in power generation and distribution network, to provide safe and cost-effective energy to its consumers. Safety of plant and equipment, as well as operating personnel, is one of the major thrust areas for maintaining the sustainability. A pre-engineered building, or PEB, is primarily a structural steel building, where components are prefabricated at manufacturer's plant. Prefabricated parts are brought to site for erection by assembling with different components. This new concept is time-saving, cost-effective, and a unique space-saving solution. PEB construction requires much less manpower and is environment friendly. This modern civil engineering concept has been implemented at 132 kV Majorhat substation and now under execution in a few ongoing projects. Prinsep Street substation is now being re-engineered for capacity augmentation from 250 MVA to 325 MVA and voltage upgradation from 132 kV to 220 kV to draw additional power to meet system growth. The network reorganization is being done, maintaining all existing supply. CESC has implemented many pilot projects with the latest technologies and has plans to install similar equipment in upcoming projects. Four-winding transformers, a new concept in power distribution, installed at Patuli substation, integrates 132 by 33 kV system of substation with 33 by 11 6 kV distribution station within a single premise, thereby optimizing space and cost. This unique solution is effective for city-based utilities, where space availability is critical. Ester oil has high flash point with less carbon footprint. Transformers with ester oil can have high overloading capacity as compared to mineral oil transformers. CESC initiated installation of ester oil-filled 20 MVA transformers at a few distribution stations. Gas-insulated transformers are non-explosive and compact and are ideal for underground installations. Power transformer with unit cooler radiator banks occupies 35 to 40% less space. Power transformers of 100 MVA capacity are already installed at different substations in recent years. 33 kV GIS boards are installed with bay controller units at different distribution stations for integrating protection system with GIS, thereby eliminating conventional RCI panels, resulting in cost and space optimization. Non-conventional instrument transformer reduced failure rate and high flexibility gives the system a cutting-edge advantage. In today's smart digital world, we want our old electric grid to behave like a smart grid to make life easier. But it brings new challenges like: how can we control our power bill and reduce cost? How can we adopt new green source of energy and reduce carbon footprint? How can the utility control the meter remotely? How can utility better manage outage and ensure reliability? As a step to implement the smart grid, CESC is in the process of taking a number of engineering initiatives, including AMI with smart meters, AMR metering of distribution transformers, SCADA, automation, software-based comprehensive asset management, and condition-based maintenance of assets. In order to improve network reliability and faster restoration, CESC has taken a few major steps: EHT ring network, self-healing network, optical fiber-based communication, and smart network management through SCADA have resulted in faster restoration without manual intervention. Power line damage could disrupt services in a particular area, which may remain without power until the faults are attended at site. The self-healing technology helps the utility to detect the problems and isolate the damaged sections. It can also switch on the power automatically through alternate circuits, resulting in fast restoration. The entire switchover takes even less than a minute and ensures the minimal power outage. CESC's self-healing network at 33 kV distribution station resulted in restoration within 1 second. The self-healing network at 6 by 11 kV sites resulted in restoration in 7 seconds. CESC plans to deploy large-scale rollout of such self-healing schemes. CESC plans to implement Geographical Information System or GIS for various smart applications and better customer service. The GIS shall be integrated with SCADA and other enterprise applications. Smart metering is an ambitious project for utility. To achieve the goal, utilities require an efficient rollout process. Capture consumption data. Manage remote disconnection and reconnection. Manage payments, and so on. Smart Meter AMI project is in progress at Jodhpur Park. This digitalization process is a landmark initiative by CESC towards enriched meter data analytics and use of artificial intelligence in metering solutions using real-time data. The RF mesh communication canopy has the future potential to integrate various applications like water and gas meters under different business models. CESC adopted proactive network health monitoring using futuristic technologies and prevented many system faults since 2010. thereby improving supply reliability over years. CESC is the first Indian utility to undertake a pilot for automatic location of cable partial discharge on real-time basis. CESC ventured into a project with IIT Kharagpur for IoT-based solutions for remote sensing and monitoring of partial discharge and hotspots by using drones with thermographic cameras and wireless sensors. Through statistical analysis and artificial intelligence applications, CESC is in the process of predicting cable faults before occurrence. Centralized Protection Management System from CESC Testing Department helps in faster restoration and analysis of system disturbances. CESC is commissioning Phaser Measurement Unit for its distribution network for better analysis of system disturbances. IoT implementation initiatives of CESC include FPI monitoring of RMUs, self-healing feeders, monitoring of transformer temperatures and vibrations, HT consumers and pillar boxes. Electric vehicles are going to spearhead the future transportation in India. And 30% of vehicles shall be electricity driven by 2030. Central government already proposed an ambitious plan to promote such EVs in the country. CESC is already in possession of EVs and installed a few EV chargers at various locations, where an electric car can be fully charged in only 90 minutes through a DC charger. As a shift from centralized fossil fuels to decentralized green energy, rooftop solar panels would reduce peak demand, ensuring grid stability. Such panels may be used to meet auxiliary power requirement of substations and distribution stations. CESC has plans to implement Smart Outage Management System for all consumer outages through Centralized Complaint Management System. GPS-enabled power restoration team gets instant alerts and necessary steps are taken to restore power in the shortest time. In order to improve on customer centricity, initiatives are taken to create app-based virtual office to enhance increased customer participation. Various services like SMS services, social media connects, web services for complaint lodging, online bill payments, new connection applications are serving the consumers on 24/7 with ease. Businesses use chatbots to talk one-on-one with millions of customers via messaging. Instead of consumers emailing us a question, they can directly message the chatbots to get answers instantly. Instead of calling to set up an appointment, consumers can directly text to schedule appointments straight away. In a world where messaging apps have become the most popular form of communication, chatbots are set to become the primary way consumers communicate with the businesses. CESC has implemented chatbots utilizing artificial intelligence for prompt consumer services. As power generation sources become increasingly distributed, intermittent and volatile, Achieving the levels of control and performance requires a more intelligent, efficient and reliable grid. This is now possible in grid automation technology in recent years, including the development of digital substations. It involves digitalization at station and process level, cybersecurity and asset management, as well as data-centric grid operations through integrated engineering. With a focus on reducing the total cost of ownership, digital substation technology facilitates lesser maintenance costs, avoids outages, has the least footprint and ensures sustainable grid availability and maintaining right regulatory compliance. Digital substations have shorter erection time and reduced construction and maintenance costs. All communications are carried out by optical fiber cables. CESC is planning to commission such digital substations in the current fiscal. CESC is in the process of setting up a smart grid-centric distribution training institute to cover home automation, simulation of smart metering with AMI, self-healing network, amongst many other initiatives. CESC is planning to replace the existing SCADA EMS and DMS systems with OMS-centric SCADA EMS and DMS systems, which will be capable of integrating various enterprise applications, including GIS and future MDMS. Upgradation of existing telecom system with state-of-the-art MPLS TP platform. CESC also has plans to integrate smart grid control room covering DSM, MDM and CRM systems. The primary focus of the generation business is to improve business excellence and to establish CESC as a leader in power generation industry. CESC has already invested in various IT and OT infrastructure as a path forward towards digitalization. Already implemented technologies include condition-based monitoring analytics tools for vibration measurements of rotating equipment, RCM tools, PADO, online energy monitoring system, and online measurement of GCV value of coal. CESC is looking forward towards integration of IT and OT platforms, as well as various Internet of Things, as a step towards Industry 4.0, with the introduction of mobile application tools for regular monitoring of data. To get a higher visibility and prediction of future scenario with the help of analytics-based software and tools, CESC shall require solution which shall include IT, information technology and OT, operational technology, to get real-time solutions. The future shall see more integration of IT and OT and introduction of digital technology in a cyber-secured environment. The truck cycle and delay automated data collection system is proposed to be implemented for monitoring coal logistics by road and shall be able to track vehicle payload and truck cycle during dumping operation. This shall lead to reduced penalties on account of haulage of vehicles at plant and increase the efficiency of carrying out dumping operation of coal. In the event of ever-changing scenario of power system dynamics, grid stability has achieved paramount importance, not only to maintain grid frequency, but also to cater to demand surges as per requirement of unscheduled interchange. As we move to the future grid, we shall see ever-changing input mix of both renewables and non-renewables. CESC proposes use of such advanced DSM packages, which shall be equipped with higher degree of analytics-based tools to predict better load requirement, to enable power stations to automatically adapt to the fluctuating load demands with quick response. digitization of equipment level identification through value-added mobile apps, RFID and QR codes will facilitate ease of operation and maintenance of plant, thereby improving reliability, efficiency and safety. Augmented reality and virtual reality are the future untapped areas where CESC is interested to venture. 3D simulation of real-time augmented reality of actual circuit diagrams, process flow diagrams shall provide better visibility for quick and safe response during maintenance, thereby drastically reducing downtime. Use of working robots in place of humans for boiler tube inspection and welding shall appreciably reduce the downtime and also increase the plant availability. Drones may be used for coal yard stack pile calculation and for hot surface detection. Drones can also be used for stringing of transmission lines. The MOEF and PCB have set the guidelines for setting up the flue gas desulfurization units within 2022. CESC is also trying to comply with the norms, and various cost-effective solutions are invited for setting up FGD plants and to locate suitable buyers for disposal of byproducts like gypsum, ammonium sulfate and sulfuric acid. CESC is steadily preparing for implementation of contemporary cutting-edge technologies in its distribution system and generating stations. CESC welcomes the valued partners to showcase their latest engineering concepts for taking such initiatives further in the coming years.